Hi, and welcome to Prototype. We'll be solving the problem for LeetCode 102 binary tree level order traversal. This is another problem in the LeetCode 75 study plan. Let's get to it. So given the root of a binary tree, return the level order traversal of its nodes' values from left to right, level by level. And they give an example with the tree with root node 3, and it has children 9 and 20, and then the child with the value 20 has children 15 and 7 in order from left to right. And it wants us to output a nested array with the same number of elements as the tree's height, and then each array will have the node values from each node in the tree, again from left to right. Okay, so this is a breadth first, and we're not really searching anything, so let's call it breadth first visit. So we're going to go level by level, left to right. Let's do a recursive solution first. We'll have a result variable. It will be initialized to an array. We will return the result variable in the end. We will need some sort of helper function. Let's call it BFS, and BFS will require the current node. And then let's also keep track of the index. And here the index will refer to the index of the element in the result array. We can refer to the index as the level in the tree. But instead of calling it level, I'm going to use a zero-based index so we don't have to do any offsets. Again, so if 3 is in level 1, it will have the index 0, okay? And what is the base case? Well, if the node is null, we can just return. Else, what are we trying to do? Well, we're trying to add the visited node's value into a level array or indexed array. And so if that array doesn't exist, we'll have to create one. Okay, so if result index does not exist, then result.push again and create a new array, and then we will have the node value inside. Else result index push the current visited node's value. And because this is a breadth first search, if the child to the left exists, then we will call BFS on that child, so node left. And then we will also have to pass the current node's index, and then because it's a child of the current node, we'll have +1. And then same with the right side. Call BFS on node.right, and then pass index +1. At the end, we will need to call BFS on the root node, and it will start with index 0. Run it. Oh, root, of course. Run it again. Okay, and submit. Okay, so this recursive solution apparently beats 93.8%. Very quickly here, in terms of time complexity, we will be visiting every single node once to get the value, right? So this is linear time complexity, where n is the value of nodes in the tree. And in terms of memory complexity, well, it will also be linear because we'll be adding to the call stack on every node as well. Okay, so let's talk iteratively. Oh, hold on, actually. So I'm actually going to keep some of this in the iterative solution. Let's pull the base case out. Now, instead of checking the node, we'll be checking the root. So if the root is null, then we will return an empty array. Okay. Else, and the reason why I wanted to keep this code actually is because these 4 lines will be very, very similar to the recursive call. Now, with iterative solution, let's use a trusty while loop. And what will we be depending on? Well, we'll need some sort of storage mechanism to hold the next nodes to be visited. With breadth first, let's use a queue, and we'll simulate a queue with an array. Again, JavaScript doesn't have a actual queue object, so we'll just simulate this with an array. And what will be inside the queue? The node to be visited, which, oh, sorry, is the root. And we're going to actually add one more thing to keep track of, and that is the index, right? So, and what is the first index? It is 0. Okay. So what is the while condition? Well, while the queue length is greater than 0, what are we going to do? We need to dequeue the next node to be visited, and with a bit of JavaScript magic, we're just going to destructure here. And we call shift. Shift in JavaScript takes the first element in the array. Now, again, quick aside, this is not the best solution because JavaScript doesn't have a queue object, and so calling shift on an array is a linear time operation, so definitely not the best, but shows the point anyway. And okay, what are we going to do after we dequeue the current node and the current node's index? Well, we'll be doing the same thing for the first 2 lines. If the current results level array, if you want to call it that, doesn't exist, then push a new array with the node value, else get that level array and then push the current node's value. And then we will have to also not call it BFS, but we'll be adding the child to the queue so that it can be dequeued and run this loop as well. And we will be just wrapping this in an array because that's how we are going to keep track of the node and its index. All right. That looks good. Let's run it. Okay, and submit. And there we go. So apparently it beats 95.89%, which is funny because this is, again, pretty slow operation right here. So again, this could be improved if you used your own queue object, for instance. Then you get rid of this linear time complexity based on the queue length operation here. But okay, that is the solution recursively and iteratively for LeetCode 102 binary tree level order traversal. Subscribe to see more. We will be doing the rest of the LeetCode 75 study plan questions in short order. Thank you, and see you next time.